At 13:42 hours on June 4, 1942, Lieutenant Junior Grade William Earl Gallagher rolled his Douglas SBD Dauntless dive bomber into a 70-degree dive toward the Japanese aircraft carrier Kaga. Below him, 21 Mitsubishi A6M Zero fighters orbited at 10,000 feet, protecting the carrier from attack. They were too low. Gallagher's dive bomber section was attacking from 19,000 feet, 9,000 feet above the combat air patrol. By the time the Zero pilots saw the dive bombers, it was too late. The SBDs were already in their dives, accelerating past 250 knots, dropping toward the carrier at 4,000 feet per minute. The Zeros climbed desperately their Nakajima Sakai engines, screaming at full power, but they could not intercept. 3 1,000-pound bombs hit Kaga in rapid succession. The first penetrated the flight deck and detonated in the upper hangar where aircraft were being armed and fueled. The explosion ignited aviation fuel, touched off munitions, and started fires that spread instantly through the hangar spaces. Within 4 minutes, Kaga was burning uncontrollably. One Zero pilot, Petty Officer First Class Makoto Endo, attempted to land on Kaga's deck despite the fires. His aircraft had been hit by defensive fire from the American dive bombers. A single .50 caliber bullet had penetrated his left-wing fuel tank. Fuel was streaming from the puncture and his engine was losing power as the tank drained. Endo could see Kaga's deck through the smoke. The forward section was still clear of flames. He lined up for landing, dropped his gear and flaps, and committed to the approach. At 200 feet altitude, his engine quit completely. Out of fuel, the Zero glided the last 100 yards and touched down on Kaga's deck at 13:46 hours 4 minutes after the first bomb hit. Endo scrambled from the cockpit and ran forward away from the spreading fires. Behind him, his Zero burned as flames from the hangar deck consumed it. He reached the ship's island structure and looked back at his aircraft, watching it disappear into the inferno. That Zero, like most of the aircraft on Kaga, had no self-sealing fuel tanks. A single bullet hole drained the entire contents of the wing tank in less than 4 minutes. The fuel spilling into the wing cavity and trailing behind the aircraft as vapor had not ignited only because the bullet happened to pass through without creating a spark. If it had ignited, Endo would have died in flames long before reaching the carrier. This was the fundamental design flaw that would turn the A6M Zero from the most feared fighter in the Pacific to the most vulnerable. Superior range and maneuverability purchased by eliminating every safety feature, every redundant system, every protective measure that might save a pilot's life. The Zero could outfly any Allied fighter in 1941 and early 1942, but it could not survive being hit. And by mid-1942, American pilots were learning how to hit it. The A6M Zero was designed to meet a specification that seemed impossible in 1937. The Imperial Japanese Navy issued requirements for a carrier-based fighter with speed of 310 miles per hour, climb rate of 3,000 feet per minute, endurance of 6 to 8 hours, including auxiliary fuel tanks, armament of 2 20mm cannons, and 2 7.7mm machine guns, and maneuverability superior to all existing fighters. These requirements were contradictory. High speed required powerful engines and streamlined airframes. Long range required large fuel capacity, which added weight. Heavy armament added more weight. Superior maneuverability required lightweight and large wing area. No existing fighter combined all these characteristics. Mitsubishi's chief designer Jiro Horikoshi solved the problem by eliminating weight wherever possible. He designed the lightest possible airframe using a new aluminum alloy called Extra Super Duralumin, developed specifically for the Zero. This alloy was 30% stronger than conventional aluminum, allowing thinner gauge metal in the wing skins and fuselage structure. He eliminated all protective features, no armor plate behind the pilot's seat. No armored glass in the windscreen, no self-sealing fuel tanks, no fire suppression system, no redundant control systems. Every component that added weight without directly contributing to speed range or maneuverability was removed. The result was an aircraft that weighed 3,704 pounds empty, extraordinarily light for a fighter with the Zero's size and capability. The American F-4F Wildcat, a similar carrier fighter, weighed 5,658 pounds empty. The Zero was 2,000 pounds lighter despite having comparable dimensions and armament. That weight saving gave the Zero performance that shocked Allied pilots when they first encountered it. Maximum speed was 331 miles per hour at 16,000 feet. Climb rate was 3,100 feet per minute. Service ceiling was 33,000 feet. Combat radius with drop tank was 200 miles, twice that of any Allied fighter. Turn radius at 230 miles per hour was 525 feet tighter than any Allied fighter could match. The Zero first entered combat in July 1940 during operations over China. The Imperial Japanese Navy Air Service deployed 13 A6M Model 11 fighters to support operations in central China. On September 13, 1940, Zero fighters encountered Chinese Air Force fighters for the first time. The engagement lasted 6 minutes. Zeros shot down 27 Chinese aircraft without loss. This performance pattern repeated throughout late 1940 and 1941. Chinese pilots flying Soviet-supplied I-15 and I-16 fighters could not compete with the Zero's speed climb rate or maneuverability. Chinese losses mounted into the hundreds. Survivors reported that the Japanese had introduced a new fighter far superior to anything previously encountered. Western intelligence agencies received these reports but largely dismissed them. The reports claimed a Japanese fighter with 200-mile range, 330-mile-per-hour speed, and extraordinary maneuverability. Western aeronautical engineers calculated that such performance was impossible within the weight constraints of carrier operations. The reports must be exaggerated, possibly describing multiple aircraft types confused by pilots under stress. This assessment was catastrophically wrong. When Zero fighters escorted bombers attacking Pearl Harbor on December 7, 1941, American forces encountered the aircraft for the first time. The performance was exactly as reported from China. American fighters attempting to intercept were outclimbed, outmaneuvered, and shot down. Of the approximately 30 American fighters that got airborne during the attack, at least 10 were destroyed by Zeros. Over the following 6 months, from December 1941 through May 1942, Zero fighters achieved air superiority throughout the Western Pacific and Southeast Asia. Zeros escorted bombers attacking the Philippines, Malaya, Singapore, the Dutch East Indies, New Guinea, and the Solomon Islands. They destroyed Allied aircraft by the hundreds: American P-40 Warhawks, British Hurricanes, Dutch Brewster Buffaloes, Australian Wirraways. Allied pilots reported that the Zero could outturn, outclimb, and outrange every fighter opposing it. Standard fighter tactics, turning combat, climbing combat, running combat, all failed against the Zero. American fighter pilots in the Philippines suffered 50% casualties during the first 2 weeks of combat. British pilots in Malaya suffered similar losses. The Zero's dominance appeared absolute. Japanese pilots believed they were flying an invincible fighter. Some American intelligence officers estimated it would take 2 years to develop a fighter capable of matching the Zero's performance. But the Zero's vulnerability was already apparent to anyone who looked carefully at combat reports. The aircraft burned easily when hit. Pilots who bailed out were often severely burned. Aircraft that were damaged often did not return to base, apparently lost to fuel starvation or fire. The few Zeros that had been shot down and examined on the ground showed remarkably thin skin, minimal structure, and complete absence of protective features. The first intact Zero recovered by American forces fell into a bog on Akutan Island, Alaska, on June 4, 1942, the same day as the Battle of Midway. The pilot, Petty Officer First Class Tadayoshi Koga, had been escorting bombers attacking Dutch Harbor when his Zero was hit by ground fire. A bullet severed his fuel return line. Koga attempted an emergency landing on Akutan Island, which Japanese planners had designated as an emergency field for damaged aircraft. But Akutan Island had no prepared runway. Koga was supposed to land on a grassy area that appeared flat from the air. It was actually a bog covered with thick moss. When Koga touched down, his landing gear sank immediately into the soft ground. The Zero flipped onto its back. Koga, not wearing a seatbelt because the Zero had no provision for seatbelts, broke his neck when his head struck the canopy frame. He died instantly. The Zero remained on Akutan Island for 5 weeks before American forces discovered it during mop-up operations. Naval intelligence officers recognized immediately what they had found. The Zero was intact except for the crumpled fuselage from the crash. It could be repaired and flown. The aircraft was shipped to Naval Air Station North Island in San Diego, where technicians spent 6 weeks rebuilding it. They replaced the damaged fuselage sections, repaired the engine, and restored it to flying condition. On September 20, 1942, test pilot Lieutenant Commander Eddie Sanders flew the captured Zero for the first time. The test program that followed revealed everything about the Zero's design philosophy and its vulnerabilities. Sanders and other test pilots flew the Zero against every American fighter type: F-4F Wildcat, F-4U Corsair P-38, Lightning P-40 Warhawk P-51 Mustang. They tested turning performance, climbing performance, diving performance, speed, and acceleration. They fired machine guns at the Zero's structure to determine vulnerability to various types of ammunition. The results were compiled into a detailed technical intelligence report distributed to all fighter squadrons in the Pacific. The report identified the Zero's strengths: extraordinary maneuverability at low and medium speeds, excellent climb rate below 20,000 feet, very long range. But more importantly, it identified exploitable weaknesses. First, the Zero could not dive. American fighters had rugged structures and high wing loading that allowed diving at speeds exceeding 400 miles per hour. The Zero's light structure and low wing loading made high-speed dives dangerous. Above 300 miles per hour, control forces became excessive. Above 350 miles per hour, the ailerons became nearly immovable. Pilots attempting high-speed dives risked structural failure or loss of control. Second, the Zero's roll rate was poor at high speeds. The light fabric-covered ailerons that provided excellent control at low speeds became ineffective at high speeds due to aerodynamic loads. American fighters with metal ailerons and hydraulic boost could roll much faster. Third, the Zero's engine lost power rapidly above 20,000 feet. The Nakajima Sakai engine used a single-stage supercharger that provided good performance at low altitude, but poor performance at high altitude. American fighters with two-stage superchargers maintained power to 30,000 feet or higher. Fourth, and most critically, the Zero's fuel tanks were completely vulnerable. The aircraft carried fuel in 2 wing tanks, 1 fuselage tank, and a drop tank when fitted. None were self-sealing. A single incendiary bullet through any tank would drain it rapidly, often with catastrophic fire. The technical intelligence report recommended specific tactics. Never attempt to dogfight a Zero. Never try to outturn it. Never climb slowly in front of it. Instead, use speed and altitude advantage. Dive on Zeros from above, shoot in a single high-speed pass, then extend away in a dive. Use superior diving speed to escape. Use superior high-altitude performance to maintain altitude advantage. Concentrate fire on the wing root area where fuel tanks are located. These tactics, summarized as boom and zoom, became standard for American fighter pilots facing Zeros. The tactic was simple in concept, but required discipline to execute. Pilots had to resist the temptation to turn with Zeros, had to maintain speed, and altitude advantage had to accept that many attacks would not result in kills. But when executed properly, the tactics worked. By late 1942, American fighter squadrons, using boom and zoom tactics, were achieving favorable kill ratios against Zeros. The F-4F Wildcat, which had been considered inferior to the Zero, began destroying Zeros at a rate of 5.9 to 1 when flown by properly trained pilots using correct tactics. The vulnerability of the Zero's fuel system became notorious. American pilots learned that a short burst of .50 caliber incendiary ammunition into the Zero's wing root would almost certainly set the aircraft on fire. The combination of unprotected fuel tanks, lack of fire suppression, and large volume of fuel created a fire hazard unlike any other aircraft. Lieutenant Commander John Thatch, who developed the Thatch-Weave defensive tactic against Zeros, observed that Zeros burned far too easily. A short burst would set them on fire, and once burning, they were finished. The pilot had maybe 10 seconds to bail out before being overcome by flames. Statistics from combat after mid-1942 confirmed this vulnerability. Analysis of Zero losses showed that approximately 65% of Zeros shot down caught fire after being hit. Of pilots in Zeros that caught fire, approximately 80% died either in the aircraft or shortly after bailing out, many from severe burns. The survival rate for Zero pilots shot down was approximately half that of American fighter pilots shot down. The Imperial Japanese Navy recognized the Zero's vulnerabilities by 1942 and attempted to address them in later models. The A6M Model 22, introduced in December 1942, had slightly thicker wing skins and reinforced structure. But weight increased by 200 pounds, reducing maneuverability, without significantly improving survivability. The A6M Model 52, introduced in August 1943, had further structural strengthening, including heavier wing skins and improved diving characteristics. Maximum diving speed increased from 310 miles per hour to 410 miles per hour, but weight increased another 300 pounds, further reducing maneuverability and climb rate. Some A6M aircraft received self-sealing fuel tanks in the main fuselage tank only. The wing tanks remained unprotected due to weight considerations. This partial protection provided minimal improvement. Most Zeros continued to be lost to fuel fires after wing tank hits. The A6M variant, introduced in October 1944, finally incorporated comprehensive self-sealing fuel tanks in all fuel cells. It also included armor plate behind the pilot's seat and armored glass in the windscreen. These modifications increased empty weight to 4,136 pounds, 432 pounds heavier than the original A6M2. The weight penalty devastated performance. Maximum speed decreased from 331 miles per hour to 305 miles per hour. Climb rate decreased from 3,100 feet per minute to 400 feet per minute. Turn rate decreased by approximately 15%. The protected Zero was significantly inferior in performance to the American fighters it faced: F-6F Hellcat, F-4U Corsair, P-38, Lightning, P-47 Thunderbolt. Japanese pilots complained bitterly about the A6M. The protective features degraded the Zero's only remaining advantage, maneuverability, without providing adequate protection. The self-sealing fuel tanks used multiple layers of rubber and fabric that would swell when punctured by fuel-sealing small holes. But .50 caliber armor-piercing incendiary rounds would punch through the sealing layers, creating holes too large to seal. The armor plate behind the seat was only 8 mm thick, adequate against 7.7 mm rounds, but inadequate against .50 caliber rounds. Production of the A6M was limited. Most Zero production continued to be A6M models without comprehensive protection. By late 1944, approximately 70% of Zeros in service had no armor protection and no self-sealing tanks. They remained as vulnerable as the original A6M2. The Zero's vulnerability created a death spiral for Japanese naval aviation. Experienced pilots were killed at unsustainable rates. Replacement pilots received abbreviated training due to fuel shortages and the urgent need for replacement aircrew. Poorly trained pilots died even faster, creating an accelerating demand for more replacements. By mid-1944, the average Zero pilot had approximately 100 hours total flying time compared to 300 hours for American carrier pilots. Many had never fired their guns at aerial targets before entering combat. Some had fewer than 50 hours. These pilots stood virtually no chance against veteran American pilots flying superior aircraft using proven tactics. The Battle of the Philippine Sea in June 1944 demonstrated the result. Japanese carrier aircraft, mostly Zeros, attacked American Task Force 58 in waves. American fighters intercepted using radar vectoring altitude advantage and boom and zoom tactics. The Japanese lost approximately 330 aircraft in one day. American losses were 31 aircraft, mostly operational accidents. The engagement became known as the Great Marianas Turkey Shoot. Combat film from that battle showed Zero after Zero catching fire from short bursts of .50 caliber fire. Zeros would be hit trail smoke for a few seconds, then explode into flames. Pilots who bailed out were often on fire. The vulnerability that had been designed into the aircraft in 1937 to achieve range and maneuverability had become a death sentence for the pilots flying it in 1944. Some American pilots expressed sympathy for Zero pilots. Lieutenant Hamilton McWhorter, a Hellcat pilot who shot down 8 Zeros during the Marianas Turkey Shoot, later wrote, "They were flying gasoline cans. We knew it, they knew it. Every time I hit one, it would light up. I felt bad about it, but this was war." The Zero pilots were brave men flying a death trap. The Imperial Japanese Navy attempted to develop a replacement for the Zero. The Mitsubishi J2M Raiden and Kawanishi N1KJ Shiden were designed as heavily armed, well-protected interceptors. But both types suffered development problems and entered service in small numbers too late to affect the war's outcome. Zero production continued through 1945 with over 10,000 built, more than any other Japanese aircraft. By 1945, Zeros were being used primarily for kamikaze attacks. The aircraft's long range made it suitable for one-way missions to distant targets. Its vulnerability no longer mattered when the pilot intended to crash into the target. The design compromises that made the Zero vulnerable in air combat were irrelevant for suicide missions. The final Zeros were expended during the defense of Okinawa from April through June 1945. Hundreds of Zeros, flown mostly by minimally trained pilots, attacked American ships in kamikaze missions. Most were shot down by anti-aircraft fire or combat air patrol before reaching their targets. Those that penetrated the defenses caused significant damage, but the loss rate was over 90%. After Japan's surrender, Allied technical intelligence teams examined surviving Zeros in detail. Engineers from Grumman Republic and North American studied the Zero's structure systems and design philosophy. The consensus was that Horikoshi had created a brilliant design within the constraints he faced. In 1937, when the Zero was designed, Japan lacked the advanced materials manufacturing techniques and powerful engines available to American and British manufacturers. Japanese industry could not produce aluminum alloys as strong as American alloys, could not manufacture engines as powerful as American engines, could not fabricate self-sealing fuel tanks with the same efficiency as American manufacturers. Horikoshi maximized performance using the technology and materials available. He created an aircraft that met its specification and dominated early Pacific air combat. But the design had no margin for improvement. When American industry produced fighters with 2,000 horsepower engines, self-sealing fuel tanks, pilot armor, and structural strength adequate for high-speed combat, the Zero's design advantages became irrelevant and its design compromises became fatal. American engineers noted that the Zero represented a fundamentally different design philosophy. American fighters were designed to protect the pilot, first achieve performance second. Weight margins were built in for armor fire suppression redundant systems. If these features reduced performance, the solution was more powerful engines and better aerodynamics, not elimination of protection. The Zero was designed to maximize performance using minimal resources. Protection was sacrificed to achieve range and maneuverability that Japanese industry could not achieve through superior engines or materials. This philosophy worked when Japanese pilots were highly trained and American pilots were learning. It failed catastrophically when American pilots became proficient and Japanese pilot quality declined. Post-war analysis estimated that approximately 60% of Zero losses after mid-1942 were directly attributable to fuel tank fires. If Zeros had been equipped with self-sealing fuel tanks from the beginning, Japanese naval aviation might have sustained combat effectiveness months longer than it actually did. The accumulated loss of experienced pilots might have been reduced by 40%. But self-sealing fuel tanks would have increased Zero weight by approximately 400 pounds, reducing range by 20% and degrading maneuverability, enough that the Zero's advantage in turning combat would have been minimal. The Zero might not have achieved dominance in 1941-42, might not have shocked Allied forces with its performance, might not have contributed to the rapid Japanese victories in the war's opening phase. Horikoshi was questioned about these design choices after the war. He stated that he had designed the Zero to meet the Imperial Japanese Navy's specification, which explicitly prioritized range and maneuverability. The Navy had calculated that carrier operations in the Pacific would require long-range fighters to escort bombers attacking targets hundreds of miles from carriers. Without that range, carrier operations would be ineffective. The Navy had also calculated that Japanese pilots who were better trained than American pilots in 1941 would win dogfights if they had superior maneuvering aircraft. Both calculations proved correct in 1941-42. Both became irrelevant by 1943 when American tactics evolved and American pilot training improved. Horikoshi expressed regret that more Zeros had not been equipped with self-sealing tanks and armor protection, but he maintained that the design was correct for its time and purpose. The Zero succeeded in 1941-42 because of its design choices, not despite them. That those same choices became fatal by 1943 reflected change in circumstances, not design error. 4 Zeros survive in flying condition. The best known is owned by the Planes of Fame Air Museum in Chino, California. This aircraft, an A6M Model 52, was captured on Saipan in 1944 and shipped to the United States for evaluation. After the war, it was preserved and eventually restored to flying condition. It is painted in the markings of the Tainan Air Group and flies occasionally at air shows. Another flyable Zero, also an A6M Hum-5, is owned by the Commemorative Air Force and based in Texas. A third flyable Zero belongs to a private collector in Japan. A fourth is owned by the Military Aviation Museum in Virginia. All four are A6M5 variants, the most common late-war version. Approximately 20 additional Zeros survive in museums worldwide. Most are displayed in the markings of famous units or notable pilots. The National Air and Space Museum in Washington, D.C. displays an A6M Zero recovered from the South Pacific. The Imperial War Museum in London displays an A6M captured in 1942. The Yasukuni Shrine in Tokyo displays an A6M that was the last Zero to land on a Japanese carrier before the war ended. The Zero remains the most recognized Japanese aircraft of World War II. Its combination of stunning early performance and catastrophic late-war vulnerability makes it a subject of continuing historical interest. It represents both the peak of Japanese aeronautical achievement in the 1930s and the limitations of that achievement when confronted by American industrial capacity. Mitsubishi A6M Zero wingspan, 39 feet, 4 inches length, 29 feet, 9 inches empty weight. 3, 704 pounds. Maximum speed, 331 miles per hour range, 1 hour 200 miles with drop tank. The fighter that dominated the Pacific in 1941 that became a death trap by 1943 that killed its pilots through design choices made years before the war began. 10 N-39 aircraft built, estimated 60% lost to fuel fires after being hit. Thousands of pilots died in flames because their aircraft had no protection, no fire suppression, no safety margin between being hit and being incinerated. The flying gas can that ruled the sky for 18 months then burned for 3 years. The Zero that couldn't take a hit because taking hits had never been part of the design specification. The fastest, most maneuverable carrier fighter of 1941 that became the most vulnerable combat aircraft of 1944, the perfect example of a design optimized for one moment in time that became catastrophically obsolete when that moment passed.